Hello, geometry students. I hope you're ready to start some fun work with pyramids and cones today. We're going to start out with a warm-up, and I'll get the slideshow going here. The warm-up deals with surface area of a cylinder, and I'm not sure if you remember how to do that, so we'll go through it. If I look, excuse me, a cylinder is made up of a top and a bottom, which in this case, those are the bases, and they are circles. And then it's got this piece on the sides, and that's the lateral surface area. So I'm going to grab my pen, and let's look at what this is made up of. We've got a circle for the base. We can think of the top. We have another circle for the bottom. I'm going to put a little plus sign in there. Plus, and let's think about this lateral area here. So I've got this top edge, which is the circumference of the base. So if I unroll it, I've got this long edge, and this needs to look like a rectangle, by the way. It's not looking too rectangular. I'll draw that better. Okay, so that long top edge is the circumference. And this side here, this is the height of the cylinder. So I'm going to put an H in there. So if I'm trying to find the surface area, I'm going to have these two circles, which would be a pi r squared for each one. And if I find the area of this, and it's supposed to look like a rectangle, mine kind of looks like a blob. Oh, that's much better. Anyway, if I try to find a area of that rectangle, it's length times width, which in this case would be the circumference times the height, right? Length times width, think of a rectangle. So if I put it all together, my surface area then is going to be made up of those two circles. So I have 2 pi r squareds. Plus I have this rectangular piece that was created when I unpeeled the outside of the cylinder. So one dimension is the circumference, which remember we have a couple of circumference formulas. I'm going to use the one with 2 pi r. And it's that times the height. That gives me that rectangular region. So that's my surface area formula, and that's going to come in handy later in this unit. So now if I want to find the surface area, I'm going to replace those with numbers. So I have 2 times pi times 3 squared, right? Remember our radius is 3 in this figure, plus 2 times pi times the radius again, but it's just singular, not squared, times the height, and the height of our cylinder is 9 inches. So I'm going to do some simplifying. 3 squared is 9. 9 times 2 is 18. So for this first part, I have 18 pi. Plus, for the second part, I have 2 times 3 is 6. 6 times 9 is 54. So the total surface area then is going to be 18 pi plus 54 pi. So our surface area is a total of 72 pi. And we can just leave it in terms of pi. It's awfully handy when we can do that. So it's 72 pi. And our units, since we're dealing with area, are going to be inches squared. Okay, area is square inches. So 72 pi inches squared would be the surface area. All right, let's go ahead and start this section. First, we have some vocabulary that starts out on page 341 in your student journal. We talk about a pyramid. A pyramid is a solid with a polygon for a base and triangular faces that meet at a point. So a pyramid can have any polygon as a base. You could have a square pyramid like the pyramids in Egypt. You can have a rectangular pyramid. You can have a pentagonal pyramid where there's a pentagon for a base. A hexagonal pyramid has a hexagon for a base, and so forth. A composite solid is a solid formed by 2 or more solids. And now we're going to jump to page 346 in our journals, because remember I talked about we're doing both pyramids and cones. So go ahead and turn to page 346 and write down the definition for lateral surface area. It sounds kind of strange. The lateral surface area of a cone is all segments that connect the vertex with points on a base edge. So in other words, the lateral surface of a cone is the parts of the cone that aren't the circle, right? All the stuff that makes up the sides. So if I were to draw what the lateral surface area of a cone looks like, it would end up looking like, if I unpeeled it, it ends up looking kind of like a little Pac-Man shape, right? If I unpeel it, all right, if I fold that all together, it would look like the sides of a cone. So a cone is made up of that. It's got the circular base, and then it's got the lateral area. Okay, so again, if you unwrap the lateral area, you get this Pac-Man shape, and then you have the base, which is a circle. All right, I put in this slide to show you what some composite solids look like. So a composite solid just means it's made up of more than one. So this one, these silos, looks like a cylinder in here, and then we've got some cones on each end. This is a traffic cone. We call them traffic cones. This part is a cone. This part down the bottom looks like a square prism. Nail polish bottle, you have a cylinder up here for the handle, and then this part again looks like some sort of rectangular or square prism. An ice cream cone, the bottom part is a cone, and this top part where the ice cream is looks like a hemisphere. This cabin, if you look, the bottom part is a rectangular prism, and the top part, if I split it where the roof is, would be a triangular prism. So all of these are composite solids. We have some formulas for volume of pyramids and cones. If you were to try to take, if you had two figures, let's say in this picture I think is in your journal, if you had a prism and you had a pyramid that had the same shaped base, and it could fit inside that prism, the volume of the pyramid would be 1/3 the volume of the prism. So the volume of a pyramid is 1/3 BH. Remember from last time, this big B represents the base area. So volume of a pyramid is 1/3 times the base area times the height. The volume of a cone, similar idea. A cone is 1/3 the volume of a corresponding cylinder that has the same base area and same height. So its volume is 1/3 BH again, or since we know we're dealing with a circular base, we can think of the volume of the cone as 1/3 pi r squared h. Okay, surface area of a right cone. The surface area is equal to pi r squared plus pi r L. So pi r squared here, so think of a cone. The base is a circle, and this is the lateral area that we talked about in the last slide, where we talked about that little Pac-Man shape. We use this L here to represent slant height. They don't use H because they don't want you to get confused with the altitude or the regular height. They don't use an S because that would end up looking like a 5. They tend to use this little lowercase italicized L to show slant height. So here I have a cone and a pyramid just with some parts labeled. So notice cones have a radius on the base, they have a height, they have a vertex. This angled edge here is the slant height. You also have a slant height in a pyramid. This edge here is called the lateral height. This is the slant height. And then the height of the pyramid is the distance, perpendicular distance from the base to this vertex up here. So again, this part down here, this whole thing would be our base area. This whole part here, the circular part, would be our base area. So we're going to jump to some extra practice on page 342. It says to find the volume of each pyramid. I'm going to grab my pen. So remember that the volume of a pyramid is 1/3 times the base area times the height of the pyramid. Okay, so one thing we have to recognize is what shape is the base area. So I'm going to outline it here. In this case, our base is this triangular region down here. See if I can outline that. Okay, so I'm just going to do a little aside here. So that base, if I can get it to right here. To find this base area, I'm looking at this triangle. If I ignore everything else, area of a triangle is 1/2 times the base of the triangle, which in this case is 6. Remember, I'm only looking at the triangle, that part I outlined in red. So 1/2 times the base of the triangle, which is 6, times the height of the triangle, and this is its height right here. It goes from the base perpendicular to that vertex. So 1/2 base times height. So I'm going to go ahead and simplify that, and then I can transfer this up to my pyramid volume form. That's beautiful. So let's see if I can write that again. So I take 1/2 of 6, which is 3, and 3 times 4 is 12. Okay, so just our base area alone is 12. So I'm going to go back up here to our volume. We're going to have 1/3 times that base area that we just said was 12. Now I need the height of the prism, not the height of that triangle, but the actual height of the prism, excuse me, pyramid, which is this distance right here. It's this altitude. So that's going to be times 9. Okay. And you have a couple different ways you can do this. You can either take 1/3 of 12 and then multiply by 9. You can multiply 12 times 9 and divide by 3. I could take 1/3 of 9 and multiply by 12. Whatever way, remember, it's just this times this times this. So I'm going to do it just left to right. 1/3 of 12 is 4, and 4 times 9 is 36. So, and we're dealing with volume. So I look at my units, we're dealing with centimeters. So the volume is 36 centimeters cubed is the volume of that pyramid. So again, you find the area of the base, which we've got was 12. It's that little triangular region. We put that in for our big B. The H comes from the height of the pyramid, and we have to remember to multiply by 1/3. Now multiplying by 1/3 is the same thing as dividing by 3. So if it's easier for you to multiply these together and divide by 3, that also works. All right, let's jump to number 4. Again, we're going to use the same volume formula. Volume is equal to area of the base times the height. So this time I'm going to look at my base. This time my base looks like a rectangle. All right, so this time big B is the area of a rectangle, and the area of a rectangle is length times width. So I have 11 times 7. So this time the base area is 77 square meters. All right, I'm going to plug that into my volume formula. Oops, looks like I left out my 1/3 here. All right, so we got to remember to put that back in. So our volume is 1/3 times the base area, which is 77, times the height of the pyramid, which is, in this case, 15. Okay, again, I try to do 1/3 times 77, but 3 doesn't divide into 77 evenly. So I'm going to take 1/3 and multiply it by 15. So 1/3 of 15 is 5. I multiply 5 times 77, and I end up with 385. And this time our unit is meters, so meters cubed. All right, number 5. Right, again, we have another pyramid. Let's look at our pyramid this time. It looks like our base has 1, 2, 3, 4, 5. So this time it's a pentagonal pyramid. Our base is a pentagon. We're still going to use the same volume formula though. It's still going to be 1/3 times the base area times the height of the pyramid. Now, if I look at this time, at this example on number 5, they tell us the area of the base. So I don't have to really do any work there. I just have to put in my 27 because that is the base area. And then I'm going to multiply it times the height of the pyramid, which is 5 centimeters. So the volume is 1/3 of 27, which is 9, multiply 9 times 5. And this time I get that the volume is equal to 45 cubic centimeters. And that's a 4, by the way. My 4 isn't looking too 4-ish. Oh, that's beautiful. I'll rewrite it over here. 45 centimeters cubed. Okay. All right, let's look at the next example. All right, number 7, this time it's giving to us as a word problem. It says a pyramid with a volume of 128 cubic inches and a height of 6 inches, and they want us to find the side length of the square base. All right, so this time I'm going to draw a little picture. I think it's helpful to have a picture to go with it. So I know my pyramid has a square base. These sides go up. Okay. So I'm trying to find the side length. Okay, it is a square. So both sides are going to be the same number. In this case, I'm just going to call them x. So let's write down our volume formula. The volume is 1/3 times the base area again, times the height. All right, let's fill in what we know. We know the volume is 128 cubic inches. We know we're going to have a 1/3. We don't know our base area, but if I were to find the area of this square base here, I'll just move this over. Our base is a square. The sides are each x. So the area of that square, this b here, would be x squared. So I'm going to fill that into my formula over here. I'm going to write in place of b, I'm going to put x squared. And then I know I'm going to multiply that times my height, and it says the height of the pyramid is 6 inches. All right, I can do a little simplifying. I can certainly take 1/3 of 6. The other thing you could do is you could multiply both sides by 3 first, but I'm going to go ahead and do this because this 6 is divisible by 3. So I'm going to simplify that way. So I have 128 is equal to 1/3 of 6 is 2, or 6 divided by 3 is 2. So I have 2x squared. And remember, we're solving for x here. We're trying to find the length of the side of that square base. So my next step is divide both sides by 2. And 128 divided by 2 is 64. So I get 64 is equal to the side length squared, x squared. So to undo something that's squared, remember we take the square root of both sides, and I get that the side length is x. So let's see if we've answered the question. Find the length of the side of the square base. So the lengths of the sides of our square base are going to be 8, and our units are inches. Okay, we're jumping ahead now to page 347. We're going to start some work with cones. And the first extra practice problem we're going to look at on 347 is number 2. So number 2 says a right cone has a diameter of 1.8 inches and a height of 3 inches. Find its surface area. All right, so we got to remember our surface area formula here. So surface area of a cone, and this is in your journal. Surface area of a cone, remember we have the base, which is shaped like a circle, so that's pi r squared, plus we have the lateral surface area, which is that Pac-Man looking shape when you unravel it. So that's pi r, and we use that L for slant height. And again, this formula is on page 346 in your journal if you need to look back. All right, so let's fill in our numbers here. I'm going to draw this cone first, just so I have an idea and I can fill in my different measurements. I probably didn't draw that big enough. All right, so here it is. We know the diameter all the way across is 1.8 inches. So if the diameter is 1.8, that means the radius is half that. So our radius is 0.9 inches. We also know the height of this cone is 3 inches. All right, so let's fill in what we know and find our surface area. So our surface area is going to be equal to pi times the radius. Remember, our radius was half the diameter. So pi times 0.9 squared, that's our base, plus the lateral area, which is the pi times the radius, which is 0.9. And then we need, the slant height. All right, so now to find the slant height, one thing you need to notice about this, and I'll try to draw, let me get a different pen here. So if I draw my height in here, if I look, I do my height down to my radius, and that meets that at a right angle. So the slant height actually ends up being the hypotenuse of a right triangle that's formed by the height and the radius of a cone. So this is, and I'm going to draw it a little bigger. So again, in this cone, this is the radius, this is the height, and this is the slant height. So if I'm trying to figure out that slant height measurement, if I need to know this, I can use the Pythagorean theorem. So I'm going to do that. I know my radius is 0.9, so I have 0.9 squared plus the height squared, which is 3, so plus 3 squared, equals the slant height squared. It's kind of hard to tell. That's one of those L's. So 0.9 squared is 0.81. 3 squared is 9. So I'm going to keep simplifying. So 9.81 is equal to the slant height squared. So again, remember to get that unit by itself, I take the square root of both sides. And so our slant height in this case is square root of 9.81, which is 3.13. Okay, so now I'm going to go back to my surface area formula, and I'm going to put in the slant height. All right, so now I'm going to put it all together. I'm going to go back to my other pen color. So now if I put this all together, I get that the surface area is we have our 0.9 squared times pi plus 0.9 times 3.13 times pi, and we end up with a total of 11.39. And again, surface area is area, so our units are square units, and in this case, square inches. And again, this was 0.81 times pi plus 0.9 times 3.13 times pi. I add those measurements together and I get 11.39 inches squared. All right, number 3, we're finding the volume of the cone. Again, the cone formula looks a lot like the pyramid formula. It is 1/3 base area times the height. But again, since the base is a circle, we can rewrite the formula for the volume of a cone as 1/3 pi r squared times h. All right, I'm going to switch colors here. All right, so we're going to fill in the numbers. We have volume is equal to, don't forget your 1/3 pi times our radius is 3 squared times the height of the cone, which is 4. Again, don't get the height confused with the slant height. When we're trying to use height in this measurement, we're talking about the altitude, the top to bottom. And if you think of this as a right angle in here, the height is the tallest part of that cone. So then I'm going to simplify. I get 1/3 times pi times 3 squared, which is 9, times 4. Okay, I multiply all that together. 1/3 of 9 is 3. 3 times 4 is 12. I end up with 12 pi. And you can leave it like that unless they ask you to round to a certain number, but I could certainly write it as 12 pi, or if you multiply by pi, that ends up being 37.7 centimeters is our unit this time, so centimeters cubed. Okay. This time it's a word problem. It says a right cone has a radius of 5 feet and a slant height of 13. Find its volume. So I'm going to draw a picture. I like to see what it looks like. So I've got a right cone here. All right, and we have, I've got to put in these things. There's a right angle. So we have, it has a height of, a slant height of 13. All right, so that's this out here. It has a radius of 5 feet. So in this case, we don't know the height, and we're going to need the height for the volume formula. Remember, volume of a cone is 1/3 times the base area. Remember, it's a circle, so pi r squared times the height. Right, well, we can start out by doing 1/3 times pi times our radius is 5 squared, but we don't know the height. So again, remember, we get this right triangle that's formed in here. So I'm going to redraw it. And to find a missing side in a right triangle, we can always use the Pythagorean theorem. So this is 13, and this is 5, and we're trying to find the height. So I'm going to use the Pythagorean theorem. I'm going to have 5 squared plus h squared, right? We're trying to find the height, equals the hypotenuse squared, which in this case is 13. Right, do some simplifying. 5 squared is 25, plus the height squared equals 13 squared, which is 169. Subtract 25 from both sides. And we get that the height squared is 144. And again, undo squares with square roots. So I get that the height of this cone then is the square root of 144, which is 12. So now I can replace this height measurement with 12. Now we have everything we need to find the volume. So I'm going to do the 1/3. I can't do 1/3 of 5 squared, right? That doesn't go in there evenly. That's 25. But I can do 1/3 of 12 is 4. So now I have, I'll go ahead and keep writing that down. We have 1/3 times pi times 25 times 12. Okay, I'm going to take 1/3 of 12, which is 4. 4 times 25 is 100. So the volume is 100 pi feet cubed. Or you can multiply 100 times pi and get 314 cubic feet. All right, let's see what we have next. This time we have a composite solid. So when you're trying to find the volume of a composite solid, you have to look at what the different parts are. So the top part up here, we have a cone. Right, this part here, let's grab the pen. Up here, this part of it is a cone. And this bottom part is a cylinder. All right, so to find the volume of the composite solid, I'm going to need the volume of the cone plus the volume of the cylinder. All right, let's go ahead and write down what those formulas are. So the total volume, the volume of the cone is going to be 1/3 times the area of the base, which is a circle, pi r squared, times its height, plus the volume of the cylinder. Its base is a circle, so pi r squared, times its height. All right, let's fill in our numbers. Okay, so first we're going to look at the cone. So we have pi times the radius of the cone was given to us. That's nice. 2 squared. And the height of the cone is this number up here, this 4, right? That's pointing to just this. The height of the cone is 4 inches. All right, so that's our cone. Plus, we now need to do our cylinder. So we have pi times, well, if I look at the cylinder, don't have any units down here, but this base of this cone is the same dimension as the base of the cylinder. So it also has a radius of 2 inches. That's where they're connected. It's right on that circular base. And now I have to look at the height, not as the height of the cone, but as the height of the cylinder. So this time my height is 5. All right, so we're going to put all those measurements together. So on this first one, we have 1/3 times pi times 2 squared is 4. 4 times 4, we have 16 over here. Plus 2 squared is 4. 4 times 5 is 20 pi. So this turns into, I can't take 1/3 of 16. I would get a mixed number. So 16/3 pi plus 20 pi. And you can get a common denominator and add those together. Or if you want the decimal approximation, it is about 79.59. We look at our units and it's inches cubed. Okay. if we did this using fractions, 20 would turn into 60/3. Oh, I could have also had this as 76/3 pi inches cubed. Okay, which is the same as 79.59 inches cubed. All right, this is your assignment. Again, remember these assignments are in Schoology and they're in multiple choice form. If you're completing them on Schoology, remember you get 3 tries for each assignment. So if you get something wrong, go back and redo it. Anyway, I hope you're doing well with learning about Chapter 11 in geometry. If you have any questions, be sure to shoot me an email and I'll answer them as soon as I can. Thanks for joining us. Good luck.